Hello, this is going to be an overview of the two-sum problem. The two-sum problem involves an array of numbers and a target number, and you need to find the two indices such that the numbers at those indices add up to the target number. So in this case, those two indices would be 2 and 3 for the numbers 4 and 9. So we'll get started. I'll walk you through both the brute force method and a linear time solution. So we'll get started with the brute force solution first. The brute force solution involves looking at every possible combination of pairs, adding those numbers together, and checking if it equals to the target number. If it does equal the target number, then you just return the indices of those two numbers. So you start out and you have a nested loop, your iteration variables I and j, and you'll start with the first combination of numbers being 3 and 2 at the indices 0 and 1. So you'll add those together, you'll get the number 5. You'll see that that is not equal to our target number, so you'll increase j to the next number, and you'll check that. So 3 and 4 is 7. That does not equal 13. So we continue this process. Similarly, 9 and 3 does not add up to 13. And we can continue this process going forward, and we'll see that, no number with, I being equal to 0, no combination of numbers adds up to 13. We'll get started. We'll set I equal to 1. J equal to 2. We'll continue this process. We'll see, this adds to 6. 2 and 9 adds to 11. 2 and 8 adds to 10. So then we'll continue this process by setting I equal to 2 and J equal to 3. At this point, we see that 4 and 9 adds up to 13. That is our solution. So we just look at these indices and we return this as our solution. So in this case, however your language syntax works, you can say like, okay, we're gonna have our answer be equal to this and then return that. But either way, this is the answer we want. And we got it through brute force, so n squared time complexity, with constant time space complexity. You know what's cooler? Linear time. So we'll come up with a solution that involves only looping over the numbers one time. And we can do that actually by using a dictionary. So we can set up a dictionary scene, is what I'm going to call it. And we can start out by just setting it to be empty. And the idea here is in scene, we're going to store all the numbers that we've seen previously, and we're going to map them to the index that we saw them at. That's helpful because while we're looping over these numbers, for any given number, I can look for this number's complement. In order to do that, I take the target number, I subtract this number from it. In this case, 13 minus 9 would be 4, right? And then I would check my dictionary to see, have I seen 4 before in my array? If it is a key in this dictionary, then the value will be the index I saw it at before. In that case, it would give me the answer. So I'll demonstrate this. Again, we're going to iterate. We'll choose I as our iterator variable. We're going to set it equal to 0 first. So we're going to check our complement. What's 13 minus 3? That's equal to 10. That obviously is not in our dictionary because this is the first number. So we're just going to ignore it, and we're going to actually add in 3 as a key to our dictionary. And we're going to set it to have a value of 0. We're going to increment I, look at 2, get its complement, which would be 11, because 13 minus 2 is 11. We'll check our dictionary and we see 11 is not in it. So then we just continue this process. I'm not removing anything. I'm just, moving these down to show that I'm adding more items to my dictionary. And I'm going to say that we've seen 2 at the index 1. We'll continue. We'll move on to look at 4 with I being equal to 2. I'll take the complement of that. So 13 minus 4 is 9. That is not in our dictionary. So we'll just do the same process. We're going to insert 4 into our dictionary. And we'll say we saw 4 at index 2. Move on to I having the value 3 for 9. We'll take the complement. 13 minus 9 is equal to 4. And 4 does exist in our dictionary. And it has the value 2. So we saw the value 4 at index 2. And that is the complement of our current number that is at index 3. So because of that, we can actually just take that index 2 in conjunction with our current index, and we can set that to our answer. We were able to do that in linear time. We did have to use linear space though, because we would have to increase the size of the dictionary linearly as we're adding one key for every number that we see. So it's a lot faster with the trade-off of using more space, but that is probably the most time-efficient way to do the two-sum problem, at least that I know of. All right, hope you enjoyed.